Okay, we're going to have some fun with trig identities and a trig equation. So the first thing we've got to do is to prove this identity. So if we look at the left-hand side of this identity, cot y minus tan y, cot y is cos y over sine y, and tan y is sine y over cos y. So cot y minus tan y is this expression here. So what can we do with this? It's not obvious what we should do necessarily, so we might just get on with doing something. On the right hand side we've just got a single term here, so it would make sense somehow to combine these two fractions here. So let's do that. Multiplying the denominators together and then simplifying the numerator, we get cos squared y minus sine squared y over sine y cos y. What can we do with that? Well, one thing we could do is divide by cos squared y. Well, why would we do that? Well, this is cot. We're trying to get things to do with tan. So that's what I'm thinking of. This isn't the only way to do this identity. There's probably a smarter way, but this is the way I'm doing it. So when I divide each of these by cos squared y, I divide that by cos squared y, I get 1. When I divide that by cos squared y, I get tan squared y. And when I divide this by cos squared y, I get sine y over cos y, which is tan y. Okay, so I've got an expression here, and at the moment it doesn't look as if it's going very far. So I'm going to try the right-hand side. See what I can do to the right-hand side. Now cot 2y is 1 over tan 2y. So what is tan 2y? Well, we know that tan of a plus b is tan a plus tan b over 1 minus tan a times tan b. This is the compound angle formula, or the addition formula. So when I put a equal to b and equal to y as well, I make those both equal to y, then this becomes tan y plus tan y over 1 minus tan y times tan y. Well, tan y plus tan y is 2 tan y, and then this is over 1 minus tan squared y. So that would be 2y there, tan 2y. So that gives me an expression for tan 2y. 2 tan y over 1 minus tan squared y. That's the double angle formula for tan. So if tan 2y is this, then cot 2y is, or cot 2y is that, just inverted it, and then 2 cot 2y is this. And that, luckily, is the same as cot y minus tan y. So we would need to just write our concluding statement. Cot y minus tan y is identically the same as 2 cot 2y. I hope you followed. Okay, so that's the first part done. Now we've got to solve this equation. So cot y plus 5 equals tan y. So I want to use the part A, the first part of the question, cot y minus tan y. So I'm going to rearrange this equation to say cot y minus tan y equals minus 5. And then cot y minus tan y, I can replace that with 2 cot 2y. So dividing by 2, I get, and then inverting as well, I get tan 2y is minus 2 over 5. Now, the domain on which we are solving this equation is y is between minus 2 pi and 2 pi. So that means that 2y is any value between minus 4 pi and 4 pi. So we need to find all the solutions to this equation between minus 4 pi and 4 pi. So the first solution is 2y equals minus 0.381. We're in radians, of course. And for tan, to find all of the other answers, because we've got to cover quite a large domain here, we add multiples of pi or subtract multiples of pi from that principal value. And when we do that, we get 8 altogether, I think. 1, 2, 3, 4, 5, 6, 7, 8. 8 values for 2y. And then when we divide by 2, we get those 8 values for y. So there we are. That's the answer to the question.